Today I'm doing another Kotlin talk. The first one was done here a year ago. So this one is not going to be an introduction, so sorry about that for those who don't know what Kotlin is. I'll give a little bit of motivation, and we'll explain the examples if there will be questions. By the way, go ahead and ask your questions as they appear in your heads. I'll be happy to answer them as I go. So today's talk is dedicated to Java interoperability, and this is a huge pain, actually. All right, so here's my absence of a legal slide. So just a short update of what Kotlin is. It's a programming language developed by JetBrains for already about 2 years, and 1 year of actually writing code in the compiler. So I like to think about it as a modern language for industry, where those two words, modern and industry, may mean whatever. In my case, they mean that by modern language, I mean a language whose compiler is smart enough to figure out how not to write boilerplate and get your things done, and gives you flexible abstraction so that you can actually put those patterns you repeat over and over again into the library and live with them without that repetition. For an industrial setting, what I mean there is that we have huge code bases, so we need static typing to aid IDEs and tools and people not breaking things all over the place. We need readability, and we need tooling support. And of course, we need interoperability. So this talk is dedicated to this matter of interoperability with whatever environment we run in. And here it's Java, but we also run in JavaScript. So there is a whole different story there, which I'm not touching on today. So the current status is that we have open sourced what we have now. It's not released yet, so we are in an M3 phase currently. We target 2 platforms, JVM 1.6, because it's the latest JVM as far as my Mac is concerned. And we target JavaScript as well. We can build with Ant or Maven, or actually Gradle probably too. And we have IntelliJ plugin there from the very start. We have something called Kotlin Web Demo, which you can play with without installing anything. And Eclipse is pending. We didn't start on it, but we're planning to. So just to give you an idea how to play with Kotlin during my talk, here is Kotlin minus demo.jetbrains.com gives you this kind of an ID in the browser, so that you can run things on the server if you want Java, or you can run some other things on the client. If you want JavaScript, it will render stuff right in your browser like this, and you can even play with it. Yeah, and you can, of course, modify the source, and it will even check the syntax for you and give you completion and stuff like that. So go ahead and play with it. You don't have to install it. Advertising over. Now, so today I'm talking about our intimacy with JVM, bytecodes, libraries, so on and so forth. And I'll start off with libraries, actually, and mostly collections, but not only, and how we deal with making the existing collections nicer without forcing people to convert data back and forth or wrap or stuff like that. And the second thing will be fighting for safety, which is today probably even score on both sides. So safety has as much on us as we on safety, because it's complicated when it comes to interoperability. And then if I have time, I'll tell you something about statics and how we don't have them. OK, let's start off with making existing things nicer. And I started with a demo and extensions in the IDE. So this is not the web demo, it's IntelliJ. Here's the hello world, and it has no extensions. Just familiarize yourself with the fun keyword. It's fun. The rest should be obvious. If you have any questions at this point, go ahead and ask them. All right. So my first example will be this Java class here. So this is a class that everybody knows called string_util. Everybody has his own string_util in the project. And I have 2 methods, capitalize and find matches, that takes a pattern and gives you a list of matches. and I failed to implement both, so they just throw exceptions. So the way I write this in Java is familiar to everybody, and nobody likes it. I just call the methods in the applicative form. And there is an alternative to doing this. You can modify the string class by adding those virtual extensions in Java 8 and be happy with your new methods. Can you? No, you can't. First of all, you only augment interfaces. Second of all, only Java people, Oracle people augment those interfaces. You don't. The string is not owned by you. So there is a known approach to mitigating this called extension methods, which are static extension methods, or, as Brian mentioned, use-side extension methods. So what we offer you here is saying whatever string .capitalize, .find matches, .whatever, where those methods are your own definitions, although you can actually call them with a dot on an instance. And completion will give you the list, and the code will write fluent, not backwards, as the applicative form gives you. Any questions here? Go ahead.
Why is there nothing in there that says that this is happening?
This is what is happening.
There's nothing in this file that tells me that this happened.
Right. Where do you import the injection?
OK. Yeah. So the question is how those extension functions come into the scope. Actually, there is something in this file. It's declarations of of those extensions. So unless they are in the same package, actually, not necessarily in the same file, in the same package, you don't have to import the extensions. This is my toy example, so I just have them in the same file. But normally, if you have them in the library, you have to explicitly import them. So here is a declaration of such an extension. I just say that this is a function for string. The string dot in front of the name means that it's an extension for the string class. And I can access my string by the name of this inside the function. This third one as pattern gives this example here. So if I want to access the string I'm called on, it's just this inside my extension function.
What's the two exclamation marks do?
Oh, yeah. So this is actually going to the second part of the talk. It's about the pain of nullable types and Java interoperability. I would much prefer not putting it there, but I want to give you a live demo. So this is how it goes, and I'll give a lot of comments on that a little later. More questions? OK, so this is pretty simple magic. I just added a bunch of static functions that can be called in this form, and this is the whole difference. Nothing else actually changes. It's all static, no dynamic dispatch, no virtual functions added, no nothing. String class is not touched at all. The second example here will be a little bit more interesting, because here is a piece of Kotlin code that iterates over a string, which is not what you normally do in Java, because string is not iterable, right? So the thing is that Kotlin doesn't care that your string is not iterable. What Kotlin cares about is that your string has the iterator method. So as long as I have my iterator with the right type returned, I'm OK. I can iterate. Now, obviously, this iterator method is an extension function. So if I navigate there, here it is. And it returns some kind of a string iterator. It's a straightforward implementation. So the philosophy behind many language constructs in Kotlin is that we resolve functions by convention, not by interface. So that if you can resolve this iterator function on your object, it's OK, you can iterate. If you can resolve whatever other convention we have, it will work. Questions here? OK, so this way, you basically can, without touching any JDK code, without making your user use this particular set of extensions, you can add nice functionality and just give the users the opt-in where you import, and you have it. That's it. Now the third example there is just actually the same as the second. It's an operator overloading, or whatever you call it. So here I have two big decimals, constructed in this funny way. So this function big actually gives me just a call to big decimal constructor, and I want to compute the mean of the two numbers by adding them together and dividing by 2. So these both plus and divide by are not built-in operators. They are, again, extension functions defined by convention with special names, so that if I navigate to the source of this plus, I get this plus implementation here that just redirects to some kind of method of big decimal. So this just to support the idea of everything works by convention, even with extension functions. By the way, John's request on adding square brackets to everything works due to this. And we do add square brackets to many things. And we also can put commas there. It works. Any questions? OK, should be pretty easy stuff.
Override the comma operator?
No. There is no comma operator. There is a comma separator.
And if you have no plus methods, the compiler will just...
Yeah, it's a compilation error. Yeah, if you don't have a plus method, it just doesn't resolve.
Do you support primitives?
What?
Do you support primitives?
Primitive types, yes, we do. So we support all the Java primitives, and they are classes that provide those methods as their members. So you cannot override a plus on an int, because int has it already, and no extension beats a member. OK, so that was an easy part. You just get a nice library and make it even nicer by adding new functions. That's it. Now let's talk about something a little bit more interesting. So here is something we all know. It's mostly citation from the collections class from JDK. Here's a method, min, that computes a minimum of a list. List is just shorter than collection, so I'm using list here. Actually, it's collection. And I have to do all this here, because Java has only use-side variants. I have to say that my t extends comparable of question mark super t, which actually is to say that comparable is contravariant in t. And my min accepts a list of question mark extends t, which means that I'm only supposed to read from this list and not modify it. This is, by the way, not correct. I'm supposed to clear this list if I want, but I cannot add new things to it. OK, so the Kotlin version of this, I would really like to make it this way. Say that t is just comparable of t, and I just take a list of t here. But now I'm in a little bit of a trouble, because list should be the same list as here. Otherwise, I'd need to convert my collection data. So if you have any kind of Java code, Java API, that gives you lists, Java util lists, I would really like to be able to call my min on those lists without any conversions. But here's my problem. Because list is invariant, and I wouldn't be able to actually pass in lists of some more specific classes, more specific objects than whatever I write as t here. Is the problem clear?
Yes.
OK, so now I'm stuck with a bunch of Java classes that are invariant, and I have to do something about it. And what I'm telling you from this point on is a plan. It's not fully implemented yet. But here's what we're going to do. We are going to say that, OK, comparable is easy. It is just contravariant. So our declaration of comparable, which actually corresponds to Java's comparable, just adds this in here, which means that Kotlin compiler understands that it's contravariant. That's it. Now, our list is covariant. We say that, OK, we have a trait called list in Kotlin, which is covariant and has get and other methods that do not modify the list. And it has a subtrait, subtype generator, a mutable list that extends list and adds the modification methods. So this one is invariant already, because you can read and write. But this one is good, and you can say on that min method, you can say just list, meaning this list. It will be OK. The question is, how do I compile this? I want them both to correspond to Java util list. Otherwise, I don't have interoperability. So there is a tedious but straightforward trick to do that. If I see this declaration in my Kotlin standard library. It's a special class, special trait. I just don't compile it at all. There is no class file that corresponds to this. It's just a virtual trait. My mutable list corresponds exactly to Java util list, so I don't compile it actually. I just say that, OK, the class file is in the JDK. Now, when I see a Kotlin function, call it copy here, that takes everything from this list to this list, I have both a mutable list to read from and mutable list to write to. So when I compile it down to Java, the whole thing will look like this, with Java util list here and the same here, because they both correspond to the same class file. Does that make sense?
Yes, but please remove trait and write type. It's a type, it's not a trait.
Oh, really? OK, we'll take that discussion offline. OK, so this conversion down below there, it's a very bad one, actually, because my mutable list is invariant, and I'm fixing t to be that. So I want a little better. But first of all, I have to tell you how I translate classes. So it's OK when I mention a type in my signature, but I have to also handle inheritance somehow. And here, it's a Kotlin class that implements this list trait, which is covariant, so has no set method. So I implement it somehow. And when I translate it to Java, I have to put the set method there to, to fully implement the interface. So what I do, I just, the compiler omits the unsupported operation exception there. And if you somehow call it, say, from Java, you just get the exception, and that's it. So this is a little bit of unsoundness we put in there in order to get the interoperability. Questions? All right. Now, if I have a little bit, yeah, go ahead.
Where's the declaration that says that your list maps to nothing in particular and mutable list maps to list?
It's a good question. So currently, there is no declaration. So it's supposed to be hard-coded in the compiler. But we're considering making it a more general mechanism and provide annotations that say that, OK, this maps to that class. Kind of native, right? But native would be ambiguous because we have native like native. OK. And I'll give you a little bit more information on custom signatures and stuff like that a little later. So now, when it gets back to variants, if you think about it, the translation I showed you before was a little wrong. Because when you access this method from Java, again, we're talking about interoperability both ways. When I'm calling this from Java, I want this to express that it's covariant. So when I translate from this to this, I should see, OK, this class in Kotlin is covariant. So when I mention it, I should in Java say !extends t. And when I encounter a mutable list, so here, sorry, it should be in, not out. As I'm going to write into this list, actually. When I say mutable list of in t, it should be translated to !super because it's projected here as well. And they both still get to the list. Any questions? OK. Yeah.
Actually, why don't you need to say out t on the first list?
On the first, because this list is covariant by nature.
Okay.
So there is no need to say that you want this to become covariant. But this is invariant, so you have to project it. It's the same kind of syntax for !super, but a little shorter. It's, yeah. OK. Now, now I'm actually in a little bit of trouble, because inside my Kotlin program, it all works pretty well. Even when I call Kotlin from Java, it's OK. But when I start calling Java from Kotlin, I have to handle somehow this kind of signature. When I have a copy method that takes a list and returns a list, and I have to figure out which list Kotlin should see when it sees this, and which when it sees this. They both could be mutable, could be immutable. I have to decide. So there is one strategy there that is somehow safer than many others, meaning that if I pass something into the Java code, it should be as permissive as possible. If I say list, it means that I can pass in a mutable list or an immutable list. But when I return, it should be as permissive as possible, meaning that the code that actually calls this function should be able to do as much as possible. So I always return a mutable list. Does that make sense?
Is there a way to tell it you don't want that?
Yes. Not very beautiful, but you can do that. Yeah. So the strategy is to make signature that is automatically loaded from Java code as permissive as we can, and it's not only like parameter type versus a return type. It's generally co versus contravariant position. Okay. Any questions? Go ahead.
This example does this list, which is a little awkward because you have the mapping to the problem of the list. But just generally types declared in Kotlin, you do this variance thing as well, where you turn it into use type variance.
Yeah, so when you have a normal type declared in Kotlin, it's compiled down to a class file. And the only thing we have to do when translating to Java is add the use type variance everywhere for it to be variant. But no funny splitting and no deciding which particular version to take when you mention it on the Java signature, because it's only one version.
This is the same solution as the Unix string functions use with respect to const and non-const.
Yeah, that's right. OK, so here's my summary for this part. So you can use JDK collections in Kotlin natively. It doesn't require you to do any conversion or any other funny operations. You can extend them with useful operations with your extension functions. You can make them variant for Kotlin so your type system treats them nicely. And that all comes at the expense of some unsoundness when you, for example, pass a read-only list implemented in Kotlin to a Java code that actually will call set. It will just blow up with an exception. This is what we have. If you have any questions or comments at this point, go ahead. All right, go ahead.
So when you say that there's no actual Java type for the read-only list, what you mean is that you're going to use the Java type of just
in the
Java
bytecode.
list,
Yeah.
Java util list, but it's not a perfect representation of it, so you could have inaccuracies.
Yes.
OK.
Yeah, by the way, you can also say exactly Java util list in the Kotlin code and get your hands on all the crappy stuff behind it, including the monitor and everything. But normally you don't have it. OK, the next part is finding null pointer exceptions. And this is where we are struggling. So Kotlin has something called nullable types. And I'll show you briefly how it works. So the thing is that for every type in Kotlin, you always know whether it can bear nulls or not. For example, this array here, the array itself cannot be null, and the strings it contains cannot be null, because there is no indication of nullability in this type. On the other hand, if we take this files variable, it's supposed to be children of some directory. This is just Java IO file. And this will be nullable twice, actually, because first of all, list files is a very nice API. It gives you null if this file does not exist or is not a directory. Thanks a lot. Second, the files the array contains could theoretically be null, because Kotlin doesn't know anything about the declaration of list files, and it just assumes everything coming from Java to be nullable. So it's pretty problematic, actually. So this question mark here, making array nullable, is good, because we want to be safe and to know that this can be null and that we have to check for it. But this one is not. So just to give you an idea on how you use nullable values, I'm removing this. It's not needed. So I cannot say files.size, for example. The compiler will complain about these files being possibly a null and me not being allowed to reference it. So the easiest way for me to do something here is say, if files is not null, then I can use the size field. It's the size property. So this, I don't know if you can see it, but the files variable is highlighted in very light green, meaning that the compiler figured out that the type has changed. And yeah, this pop-up says that it's automatically cast to a non-nullable array. After this if, of course, I don't have any more access to the members of files. I also can play other tricks, like say files double bang size, which says, OK, I'm fine, I know better. Fall back to Java semantics and just throw null pointer exception if this is null. Otherwise, call me size.
Why double bang?
Huh?
Why double bang and not single?
Sticks out very well. And another alternative for you would be to say, Elvis, this means if files is null, evaluate to null, otherwise evaluate to files the size.
Evaluate to null even though size returns an int?
Yes. Yeah, so the type of this expression is nullable int. So its type is int question mark. Yeah, so here's the story, basically. And if you just deal with raw Java, well, not raw, but pure Java signatures, you get those double bangs all over the place. Because Kotlin doesn't know what's null and what's not. And there we are. So the summary at this point would be that nullable types are probably a good idea because they, first of all, they make this ubiquitous null a legitimate value, not a sin. Right? I was told at school that you shouldn't return a null because it's dangerous. And that makes sense unless your type system actually tracks nulls properly. Compared to other ways of representing the same thing, absence of an object, for example, an option type, it's considerably better because of no overhead. You don't have to wrap things into option if you want them to be nullable or whatever. And also, compared to option, it gives you proper subtyping. Well, some people say this subtyping is improper, but I like it. Where if you have a list of string, it's a subtype of a list of nullable string. And you can pass without rewrapping everything into a different list. But all this comes at the expense of those double bangs. Go ahead.
Technically, returning null is not a problem. It's passing null, which is a problem.
OK.
Do you find yourself using double bangs in code you write a lot?
Currently, yes, but we're going to get rid of this. I'll show how. So this is a short extract from the code we use inside IntelliJ, and it's all full with not null and nullable annotations everywhere. So this is how we try to manage nullability in our code base, which is written in Java. So the idea is, so it's roughly shaped along the lines of GSR 305. It's a little different. But basically the idea is that if something says not null, then you can enable the compiler to inject the checks everywhere and to blow up if something, if actually a null goes in here or is returned. And we have static analysis inside the IDE that help us track these things. So these are not errors. These are just warnings from the IDE, but still, the IDE is very good. And this approach actually works for us. In Kotlin, we can recognize those annotations from IntelliJ's library or from GSR 305. And it's not bad. So anything that's annotated to be not null is not null. And we can remove that question mark from the type. But guess what? It doesn't solve the problem entirely. What's the remaining part? Generics, exactly. Thank you. So if you have anything inside your angle brackets, your not null doesn't actually reach there. When you have an array of file or a list of file, there is no way to annotate the type in Java, right? There probably will be a way at some point, but that point is not here, and my Mac doesn't know it. So I have to cope somehow with this case of having nullable types inside our generics. So yeah, go ahead.
It's coming in Java 8, JSR.
Oh, thank you very much. It's very good news because we have it implemented in IntelliJ for a couple of years already. Yeah, so it's actually very good news that type annotations will enable many very interesting things. Yeah, but before that day comes, and maybe even after that day comes, we use this kind of technique where in your Java code you can mention the Kotlin annotation and give a full Kotlin signature, just like this. Well, actually, you're not supposed to type this whole thing in. The workflow goes like, you write a piece of Kotlin code, it does not compile. You press some key combination, and it says, OK, I can fix it by adding an annotation. It adds the annotation, you correct the question marks here, and that's it. So this is how we are going to attack this problem. It's a work in progress, actually. So the IDE support is not there yet, but the compiler recognizes the annotations already. So you can actually use the same technique in different contexts. So first context is from the previous slide when you just manage nullability. But also, you can advise the compiler to understand a getter as a property. Automatically, we could do that, but it doesn't really work. It compromises the substitution principle if you just do it automatically for all the getters and setters. Also, you can do some signature changes, say on classes. And to declare my comparable as contravariant, I just can put an annotation on it. Now the question is, OK, this method sits in Java.io file, and this class sits in JDK as well. What do I do about it? The answer is I use external annotations. It's a mechanism used by IntelliJ for ages already, and by some other code analysis tools, where you can specify your annotations in some separate file. We use XML for that, but you don't have to. And the compiler just reads them from there and attaches to proper targets. And a good thing about the set of annotations is that actually Java analyzers could use them also to facilitate analysis. For example, nullability is clearly very beneficial for analyzing Java code today. And if you imagine me programming a lot against JDK APIs, I'll naturally generate all those annotations in maybe a day, just for them to stop annoying me. And then I can check this into the repository or distribute it somehow for everybody to use it. Any questions?
To get third-party support for them, putting them all in strings like that requires the third-party people to parse them as well.
Third-party people, yeah, would need to either use our library to parse them or something. Yeah, that's right. Well, actually, it would probably make sense to compile this down to some kind of reusable binary format or something for them not to be parsed by tools. But a big advantage of this is that it's easily parsed by people. So as documentation, it works very well. Yeah.
Are those annotations inherited?
Those annotations, let me tell you correctly, yes, they are inherited. And actually, there is a funny interaction, because if you, for example, if you extend a trait that has this get name annotated this way, you have to override it with a property, not with a method. Yeah, so Kotlin thinks that this type doesn't have the get name function. It has a name property.
So can I override, can I subclass redefine Java class that has those annotations somehow in Kotlin, then subclass in Java, subclass in Kotlin again, and not lose the annotations?
Yes. Well, I wouldn't actually bet my life on that working currently, but you will be able to. Yeah. OK, so the current hope is that this mechanism is not too bad. We didn't have time to use it enough in practice to claim that it's actually not too bad, but that's a hope. With the aid of IDE and some kind of automatical inference you can think of, you can actually infer nullability pretty well. Because the alternative to that would be to special case on Java types and make them some kind of ghetto that doesn't care about nullability. And that messes up the type system very much. So I really wouldn't like to do this. But if that doesn't work, that would be the only way to handle it, or abandon nullability altogether. OK. Any questions? OK, then I have 5 more minutes, right?
Yeah, until 4. Yeah.
OK. So I'll be very quick on statics. I'll probably cover only the first part. So as you saw, we can put functions right inside packages without having classes in the middle. And this has interesting consequences. So I have two files, file 1 KT and file 2 KT, and they belong to the same package, and they declare two functions which call each other. Now, when I compile this down to Java, a package gets a class called package name /name dot namespace. Namespace is there for historical reasons. We'll change the name. And these functions go into this class. So far, so good, isn't it? It's actually very bad. Any ideas why? Well, no. Actually, the debugger gets confused very much, because the only way to attach a source to your file is to say from which source file this namespace was compiled. And it's only one file. I can only say that this class file is got from file 1 and not file 2. And my line numbers will go from this file, even if I'm actually debugging the compute function. And this is a real problem for us, because our debugger gets confused all the time unless we play a trick. So the trick is that you actually make a proxy. So you have to introduce one new class per package. And when you have these two, you create a package class that actually redirects to two more classes, each of which corresponds to initial sources. And this is all only to support debugging. So we do care about debugging. And this is how you actually handle this. And it has an interesting consequence as well. Because when you think about having functions under packages, it's OK. But what about properties? Properties have initializers. So the code that actually initializes properties should be executed in some order. And the natural way to handle this now is to say, OK, inside the same file, they are initialized in the order they are written. And across files, they are initialized as those classes you load as long as you touch functions from those classes. Well, this is a sloppy definition on one hand. On the other hand, it's some kind of definition. You can say what will happen in every particular situation. And the JVM handles all the stuff for us, which is good. Any questions here?
Eclipse has this custom language debugger interface thingy that allows you to solve this problem. So
yes.
Or supposed to be able to let you solve it.
Yeah.
So you do something similar with the gesture IDE.
Yeah, of course we could customize the debugger. It's always a way to go, but the thing is that with this trick, first of all, we get some other benefits, and second of all, we don't have to maintain our customization to the debugger, which is good. And you can take a command line debugger and debug with it. Go ahead.
You have annotations in Kotlin?
Yes.
Can you annotate packages?
No. Okay. So what you yes and no. You cannot annotate package declarations like in every file put an annotation on a package, but we have something called module scripts. And they are supposed to handle this package annotation scenario, although the syntax has not worked out yet.
That was the leading question for why don't you just put instead of namespace class, why don't you just use packageinfo.class? We
could say packageinfo.class, although yeah, so the point of this is that you're supposed to call these methods from Java with this namespace name, and you couldn't say packageinfo.whatever. Yeah, so this is actually a class that is used from the Java client. OK, I think I'm out of time. Something I didn't cover here was how we don't have any statics in our classes, but actually have statics in our bytecode. But this is out of scope for today. So I have a resources slide. So if you're curious about Kotlin, please go ahead and go ahead and check out our documents and the demo and the code on GitHub. of course, you want to fork it and to fix our bugs and stuff like that, welcome. And I'm on Twitter, and the project is on Twitter. Thank you very much for your attention.